So, this is a keynote by Dr. Satish Jamadagni. Satish is with Reliance Jio now, 20 years industry experience in telecom domain covering devices, network, platforms and services. He has led team contributing towards product development, standard development, and he has also delivered essential patents for key organizations such as Reliance Jio, Motorola, Samsung, Nortel and Hughes. Currently the co-chair of Asia Regional Operators Group, Small Cell Forum, chair of TDS SI Study Group, which comprise of networks, active member of GTI and 3GPP. Previously served as a board of director for the International Multimedia Teleconferencing Consortium. Satish has 120 granted or pending patents in wireless devices platform and over 25 publications in the wireless telecom area. Contributes actively to this 3GPP and TDS SI and GTI. Wow, what a illustrious background, Satish. Our pleasure to have you share your knowledge with us. Please come. Thank you.
So, good afternoon. So I will talk about, thank you. I'll talk about 5G standardization, some of the gaps that are still existing in the 5G specifications, and also briefly touch upon how politics takes center stage when compared to all technicalities in standardization bodies such as 3GPP. And that's primordial, and that's very important to know, and that's precisely where most of us fail, because India has not been able to produce anything, primarily because we don't play the politics. So some of the key things that I will cover is there are gaps in the 5G specification with respect to capacity and coverage, and backhaul considerations and some of those other new considerations primarily maps onto money. But I just want to give a little bit of background as to how the 5G specification, we speak about highly 5G, it's going to save your soul, the world will run on 5G, geopolitics, how it all started. So there was this one operator and a couple of operators in the US who were sitting on unused millimeter wave bands. It was just sitting. They could not do anything. They're unused. They had spent money. They had bought the spectrum from FCC, from the US government. So they were just sitting on it. And one of the companies, Verizon, couldn't just sit there. Obviously, you had to show return on investment. And one of the managers was kicked in the ass. So he went about saying that we'll cook up a specification, 5G specification. 3GPP was unwilling to do it because they had enough of LTE work. LTE was going great, it's still going great. So they went about doing a private 5G consortium. They cooked up a specification which was called as 5G, the Verizon 5G specification. It's called something, I don't know what it's called. So that's what they did. Because some manager wanted to show return on investment on their investment, so he cooked up something called as a private consortium LTE 5G specification. Couple of Korean operators, couple of American operators got together. I think only one single American operator was involved, Verizon, and they cooked up a specification. And there was this competing operator in US, AT&T. That man couldn't sit tight because one of my competition was already cooking up, and there's a lot of heat and there's a lot of press coverage. Forget about what the technology does. Okay, it's all forgotten. It's all press coverage, the visuals. Was getting too hot for AT&T. AT&T came to 3GPP and I put in a lot of pressure. To start 5G activity. They somehow had to cook up a fast 5G. And they got in touch with all the vendors, key vendors, Qualcomm, Ericsson, Nokia, I mean, these are all the key vendors. They got in. When they were requested to fast track 5G by an operator, American operator. By the way, this American operator is a very small operator. He's got 50 million customers. But the bloody count that they have in 3GPP is enormous, disproportionate to their actual stature on the ground. So this guy pressured, so these vendors sensed an opportunity. The vendors obviously, money to be made. Not just that, it was a IPR game. So what majority of the vendors sensed was they saw a continuation of their 4G existing patents. They said, we'll cook up a fast 5G, which is based on OFDM, existing OFDM technology, which is already there in LTE. We'll do it fast, and what that gives them is a continuation of their existing IPRs. So I can charge more for the same for the same patents. You call it branded 5G, I can charge $2 more for every single device that's sold on planet Earth. I mean, that's precisely what was the thinking. And there's a lot of press which actually does speak about the numbers and how the whole game was cooked up. So fast track, we have a 5G specification, which is nothing different from LTE. Purely, I mean, if you look at the comparison between LTE and 5G as the technology exists. So obviously, there are these very small companies who have a lot of patents now, and IPR is one of the key concerns in 5G. Because much of these companies, you can also check it in their websites, they've gone public and they've published this in their web pages. One of the companies has gone public and says they'll charge $16 per phone. For a 5G phone, $16 is the IPR cost. It's just one company, plus you have additional companies. There's $2 to $3 extra of each of these companies. You'll end up paying something around $25 per 5G phone. And think of 200 to 300 million phones sold in India every year. The amount of foreign exchange will simply fly out of this country. It's as simple as that. So this is the state of affairs we are living in as far as 5G is concerned. And okay, something was cooked up. The 5G specification is up and running, and you find a lot of press saying that 5G is, when will India roll out 5G? This is a common question which keeps coming up. The fact is, the 5G specification that exists today has serious gaps, serious gaps. And if you ever see AT&T or Verizon in the US saying that I'm launching 5G, trust me, they're wasting their money. They're bluffing. They're fooling around. So it's not really worth wasting money on that, unless and until, of course, some of these key gaps are plugged in so that it makes sense. So I'm going to cover some of the key gaps which exist in 5G, technical gaps. What's happened has happened. You cannot do much, but at least going forward. So there is a discussion on the next release of 3GPP which is ongoing, which is called as 3GPP Release 17. So discussions for what gets into Release 17 is under discussion. So that's some of the things that I'll cover. What we intend to push in, so that at least some of the gaps. I mean TSDSI as in India. So we in India have a consortium, so we're trying to push technology so that we cover some of the gaps with respect to IPRs, purely from the Indian perspective, and then of course technical gaps have to be plugged in. So one of the requests that we made is we've given some of the specifications on what is the coverage that we need to have. If you look at release 15 of 3GPP, reference signals are pilot signals. So the pilot signal typically runs at or it is so orchestrated and so designed that it has a wider coverage when compared to your normal data channel coverage. A normal rule, simple wireless technology textbook knowledge. But in this case, what has happened is there's something called as DMRS. There's a reference signal, which is supposed to be some kind of a pilot signal. So that signal, the design of that is so badly done. The pilot signal, the coverage of the pilot signal, given the waveform which has been designed and whatever modulation which has been pegged onto that particular reference signal, is lesser than the data coverage of a release 15 3GPP 5G specification. So technically speaking, as it is, millimeter wave. 5G is all supposed to be millimeter wave, so the cell sizes are very, very small. On top of that, you have a screwed up 5G specification, technical specification, which is going to bring your cell size to about 200 meters, 150 meters. You're talking about 5G, which will compare with Wi-Fi. You think it's a technology that you will put outdoors? No. It doesn't make any sense. So those are some of the things which are getting fixed in release 16, not fully fixed. So release 17 will take up some of those issues, and then we are saying some of the waveforms can be changed to get a couple of dB gains, so that the same existing power levels you can still have better coverage. So that is what we are trying to push. And we are also trying to push for some narrowband IoT air interface specifications. Backhaul is a big concern, 60 gigahertz. We're trying to, there's a specification which is coming up for 5G in the 60 gigahertz band, which will primarily be used for the backhaul, but I mean that's precisely what it is. So I wanted to give a quick comparison on the LTE versus 5G actual bit-to-bit spectral efficiency, but I don't have that. But one of the other key concerns is this whole business of 5G cloud. 5G is supposed to be a cloud-based wireless technology, and that's precisely where the much of the gains in terms of ease of applicability or deployment of applications will come in. But what is the con job which is happening in the whole business of this cloud specifications? So the simple problem is, let me go to this. So if you want to put your entire core network or even your radio network onto the cloud, you need to have a proper orchestration mechanism. The orchestration mechanism is not necessarily for, it's both the control channel, data channel orchestrations, going deeper into those channels, or even simple resource orchestration, whole damn thing. How do you configure and maintain and manage your entire cloud for these services? So where is the specification for that? There is no specification for that. And that is being cooked up in multiple forums. So essentially there was a base specification which was coming in IETF. ETSI, which is the European Union SDO, took it up. They cooked up something called as a MANO, or some orchestration framework. It's a framework, mind you. I mean, it's still not a full specification. A lot of interoperability issues. Then there are these multiple of these open specification groups which have picked up and are trying to work on it. So who do you go with? So it's a question of too many open source out there, which each of them will not interwork with the other, and you're stuck with a problem of interoperability. So the whole dream was this. In 5G, you have a perfect scenario of disaggregated network. Disaggregated network is small players can get in. You have a beautiful environment where small players can come in, plug in their network, and all these network components can interwork, and you have a really good scenario in place. No, obviously it doesn't work that way, because every of these vendors have their own interests. So there's been a big scuttle job which is going on to deliberately keep it this way. Why? Because as much as there is open source, it's unusable. And if you want to say, for example, ONAP, if I want to pick up open source code from ONAP and try to deploy, it won't work. This is just a exhaustive list of libraries, and you will have to pick bits and pieces of this library and cook up a software of your own. And they know, most of the operators, they don't have the engineering skills, so you end up going to one of them, one of the OEMs again, and you're stuck with them again. You're back to 4G scenarios. And where is the promise of this whole open source business? It's a con job. It's a perfect con job. So there is another question. 5G core network, some great thing, great technology is cooking up. What is it bringing onto the table when compared to the existing LTE network? LTE, we've spent billions of dollars on LTE. LTE network has been rolled out. So billions of dollars at stake. It's been done. But 5G is supposed to bring in great things. Just have a quick look. Box to box, functional element to functional element replication of what was already existing in 4G. Nothing else. So you cut a few functions in one box, name it another box, put it in another box. Who cares? I mean, essentially it's the same damn thing which is being packaged under 5G. But vendors will tell you that please throw away your existing 4G boxes, spend another $20 billion, please buy our equipment, put it into your. So frankly, this is a con job. This is it's a sophisticated con job. That's precisely what 5G is. And so what happens is, that's one part of the story. There's nothing new coming in. Even when nothing new is coming in, for the completion of the con job, what has to happen is, if the operators really have to throw away their 4G core, where your 5G core is not bringing anything new, but you still have to shell out your money, throw them as, they have made sure that your existing LTE core, which is called as the EPC core, cannot be used in 5G. So these are the 5G deployment options. So there is something called a standalone and non-standalone options. In a non-standalone option, LTE and 5G network both are supposed to coexist in a dual connectivity mode. So your phone will be connected to both LTE and 5G. You're essentially connected to 4G plus on the data path you can have 5G booster vitamin dose. So once in a while you keep getting 5G connections, you get higher speeds and things are good. I mean, that's supposed to be what it is. What about the core? When we have to move from NSA, NSA is supposed to be the initial deployment scenarios. When we move to standalone option where you throw away the core, 5G core has to come in. I cannot use my EPC core. When I question saying that 5G core is not bringing any new functionality onto the table, why not I use my LTE core? No, that option is not supported in 3GPP. There's a lot of opposition in 3GPP. Why? Because 4 or 5 companies feel it's not required, and rest of the world is disenfranchised. So, for example, Indian representation in 3GPP is very low. Our industry representation is hardly anything, and companies from Southeast Asia, Brazil, Africa, non-existent. So they're having a field day in 3GPP. Few companies from US and Europe, they're ruling 3GPP, which is a sad job because a very long time back, 3GPP was non-existent. ITU, which is under UN, under the aegis of UN, United Nations. They were the ones who were supposed to cook up global specifications. It was their job because every single nation on earth is a member of UN. They have a mandate, so there is a global mandate. One fine day, at sea, I'm talking about these things because these are things which you don't find in any papers. The rest of the technicalities you will find it. See, it's all 5G, all specifications are out in the open. ETSI went to ITU and requested them, saying that you don't take the job of cooking up the specifications, we will do that for you. You only come up with the specifications. So today, if anything has to be called as 5G technology, the technology has to be endorsed by ITU against a specification called as IMT 2020. IMT 2020 is the requirement set coming in from ITU. So he said, you cook up the requirements, you give us the requirements, then we will cook up the technology as a consortium of all the interested parties, companies. We will come back to you and you endorse it, put a 5G stamp and be done with it. It's all good. ITU agreed in good faith a long time back when GSM technology was big and none of the other countries were anyway interested. So it was all good then. But today what has happened is it's become a lobby group of a few companies. A UN mandate has been compromised to the level where it is just a few companies running the roast. It's a failure of the UN. It's a failure of the UN. It's a failure of ITU. What the hell is an IPR regime doing based on 3GPP specifications, which was supposed to have been done by ITU? It's the failure of the United Nations. Of course, these are political stuff we are taking up one by one. This is work in progress. We're trying to take up all these issues, the right bodies. But this is precisely what it is. For a 5G, there is no better than LTE, bit to bit spectrum efficiency for a given band, you will end up paying 4 or 5 times the IPR cost than what you were already paying for an LTE phone. Today in India, for $20 you get an LTE phone. 1,200 rupees, 1,300 rupees, you get an LTE phone. LTE phone, full phone. In the 5G regime, just on the modem, Qualcomm is going to charge you $16 plus a few other companies. So it comes to about $24, $25 for the entire IPR cost on one single phone. $25 for just the IPR, I mean, just the modem, and then the modem cost, then the actual chip cost, then you have the plastic, then the rest of the components you have to build a phone around, right? So nothing less than $200, $200 to $200, $250. And how are you going to ever get scale in a country like India with that kind of price point? No, it's not going to work out. So there are certain things that we are trying to work out. So the core is a con job. The 5G whole core business is a con job. We have our reasons, I've listed it in the PPT, as to why we want this option 6. It's called as option 6. The option of using the LTE EPC with the existing 5G radio network is called as option 6. That's not supported, so we're fighting for it. It's something that we want. And we discussed 5G core is not bringing anything onto the table, nothing new. And people talk of AI ML in 5G core. I can do AI ML. I'll do my own AI ML. What is the big deal? Who wants a specification from 3GPP for me to do AI ML on my data? And if I want to peek into anybody's data, I can always do it with deep packet inspection. I'll cook up signatures. I know signatures, data signatures. I know application signatures. I'll do it myself. I mean, it's been running for ages now. I mean, no, I don't need anybody's support to really do AI ML and stuff like this. And so that's precisely what it is. We spoke about ONAP. This is a consortium which has been put together by AT&T. It's primarily AT&T job. So they want their job done. So they cook up a consortium, get the job done through vendors in the name of the consortium. Free job getting done. It's like if my manager says I don't have resources for you to do a job, I'll cook up a consortium. Then I'll project a business case, and then I'll call all these vendors, ask them to invest money, ask them to send their engineers. The job is done for me. And I'll go to my manager, say my job is done. And whether the business comes or not, my job is done, my KPIs are met, I'm done. So we've been asking for, one of the interesting things which is happening in 5G is the so-called network itself opening up to all kinds of applications. So new kind of interfaces which are coming in, which are a set of APIs which is supposed to be thrown open, called as new service types. It can be vehicle-to-vehicle kind of applications. It can be broadcast applications, as I mentioned here, this MBMS. It can be broadcast application, can be vehicle-to-vehicle application, can be drones. If a drone services layer wants to talk to a network, drones are hovering, they want to offload data, it's connected to an LTE network or a 5G network, assume that is the case. Sending data is not a big deal. You just hang a phone onto the thing, it will push all your data. That's not a big deal. But the thing is, if you want to control, and if you want to enforce a certain amount of, and if you want to integrate such kind of a control with the command control center of a typical DGCA or the DGCA, which is the Commercial Airline Authority of India, whatever that is. Director General of Civil Aviation. So they have their commands, and if you want to interface with them, you got to open up your network APIs so that they know precisely what's happening. So you got to have a certain amount of control enablement giving to them. So these are a set of APIs which will be a common framework exposed for these multiple types of applications in 5G. There is a specification group called as SA2 and SA6. They are working on it. This is something new. And this is not the exhaustive list of APIs that are coming out of 3GPP again, because in the Indian context we have agri-tech, which is specific to us. The whole drone business is not going to be just like what it is in the US, where they're thinking drones will be flying all over the place. No, it's never going to happen in India. It's going to be highly controlled. So the scenarios will be different, the APIs will be different, the way interactions will happen will be different. So we're trying to push our Indian set of requirements into the scheme of things. This is something that we are trying to do. And so when it comes to network automation, there was one more big promise of 5G, which was essentially saying that we will integrate AI ML into the 5G framework. And where exactly are they integrating the AI ML framework into the 5G scheme of things? There is a box called as Network Data Analytics Function, NWDAF. there is this box, and this box is supposed to be the AI/ML box in a 5G core. And what does this box do? It collects all data from all entities of the network, and then once you have the data in place, it doesn't give you algorithms, of course, you have to cook up your own algorithm, but it gives you the schema in which you collect the data from all these network entities, and you do this. Oh, this is fine, but there's some politics around this also. So a lot of vendors have suddenly shown less interest in this. This is a half-cooked specification. It's not a full specification. If you look at the specification number TS23503, which is a 3GPP specification, it's not a fully cooked specification. It is in work in progress. But suddenly there is another operator consortium called as ORAN, and in ORAN they're trying to cook up something called as RIC, I don't know the full form, radio interface controller. And there is supposed to be an AI/ML engine, distributed AI/ML engine, which is going to sit in your radio network one part, sit in your core network another part. And how will this NWDA fit into the grand scheme of things? I don't know. And so I mean, there's a lot of confusion in the whole business of how AI/ML is to be used, what is to be used, how it is to be used, and stuff like that. So there is a big catch in the whole scheme of things. See, if you look at even in LTE, even when we were buying equipment from monolithic vendors, the big vendors, Ericsson, Nokia's, and stuff like that. So when I buy, I'll tell you a quick experience of how massive MIMO trials have been going around. Massive MIMO, you know, it's supposed to bring in a lot of spectral efficiency, beat channel limits, and all hanky-dory stories sold to you. When we are running a 4x4 network across the country, 4x4 MIMO, you understand what 4x4 is. And we've been trying to do trials on 64x64. The promise was 4x4, what it gives you, it will linearly expand to 64x64. No, hasn't happened. And what is the gain factor that but look at it, the cost is linear, by the way, I'll tell you. Cost is very, very linear. 2 amplifiers, 64 amplifiers, filters, so many number of filters, weight, 1 kg per amplifier for the heat sink, 64 kgs is going to be, everything expands linearly except for the gains. Gains is anywhere from 1.2x to 2x. That's it. And what is the reason for this? Multiple reasons. Primarily because most of these vendors, anybody working in Nokia, oh great guys, the top cream, bullshit has been sold to you. Multinational companies, great guys, they hire the best of the best. The most lousy engineers I've ever seen in my life. Because if you go look at the scheduler designs of most of these vendors, you will be shocked to see the level of incompetent code that exists in the scheduler. But the problem is they will not open it up for you. That is a closed box. It is the playground of the vendors. It is my secret sauce. I'm not going to give it to you. How much of a lousy it is. If you actually test it on the field, it's lousy. 2.x, what the hell are you guys doing in there? Open it up. No, they won't open it for you. Tell me, okay, if it's 2.5x, I'll do my tinkering back home, and then again I'll come back and see if I can get the gains to be higher. No, it doesn't work that way. One of the attempts of this ORAN forum was to open up this or disaggregate or try to open up this so-called scheduler and your which is primarily your control, the intelligence of the controller in your radio network. You're supposed to open up that stuff. So the RIC was one part of this whole scheme where you force operators to open up their scheduler. Because one of the experiences in massive MIMO. If massive MIMO does not succeed in LTE, 5G will be a disaster. 5G will be a failure because the only spectral efficiency you're getting in 5G is because of the massive MIMO-ness of 5G. I don't want to get into the details of what massive MIMO means in LTE versus what massive MIMO means in 5G because the specification itself has been skewed. Practically, one would assume that your massive MIMO specification 5G will apply for LTE also because, come on, I mean, it's just massive MIMO, independent of any of your radio technologies. It's on top of your existing radio technology. It doesn't work that way. It's been deliberately, LTE massive MIMO spec is crude, and deliberately the 5G massive MIMO spec is great, and that is shown as difference between 4G and 5G. See, 5G spectral efficiency is here, LTE spectral efficiency is here, 5G spectral efficiency is here. Bullshit. If you do a one-to-one comparison of the massive MIMO specs there versus here, I mean, if you really apply whatever techniques are applied in massive MIMO and 5G and LTE, It's going to be the same, because the matter of the fact is OFDM, that's it, end of story. So nothing has changed on the ground. How can anything change 4G versus 5G? So even automation is a disaster, work in progress. I don't know how it will all span out, because as we stand, as I speak, this is work in progress, and work in progress, trust me, mess, a miserable mess. So this is where 5G stands today. This is precisely where 5G stands today. The start was a disaster. The whole fast 5G specification cook-up was a con job. 5G core, miserable con job if you ask me. I'm using this word con job. And yeah, countries are fighting over 5G. Why? Because it's nothing to do with 5G. I think whenever Donald Trump talks about 5G threat and all stuff, he's more referring to IoT. IoT that's a different ballgame altogether. So if you have an Alexa at home, and if you have, by the way, just to tell you the amount of threat perception there is, so essentially there's a lot of data which is coming in. So the whole idea about 5G, even though it is, I mean, technically it's a stupid spec, why there is so much of a threat perception when it comes to 5G is because everything is connected, and you have a few cloud servers where all the data is converging. All these days was fine. My mobile data, Facebook will know every damn thing about me. Trust me, WhatsApp would know who would be the next Prime Minister of India even before any of those, any of your TV channels would ever talk to you about. WhatsApp would know. Facebook would know, because you have, what is the sample size that they have with them? It's the entire connected nation. The sample of the entire connected nation is right on Facebook. You think Facebook will not know who would be the next Prime Minister of India even before he's sworn in, even before the election, even before voting happens? No, they'll know. They will very well know. And the other part is 60% of data which goes to Facebook cloud comes from India. 40–50% of data which originates, which goes into YouTube is all from India. The next time, Americans threaten we'll cut your H-1B visas, we'll say we'll cut our cords into Facebook. So 50% of their data is finished. Their stock markets will tank. No, it doesn't have to go that way, but essentially that's what it is. But it was still fine. Your data was still fine. Your phone data was still fine. But imagine your Alexa is connected to a cloud, and your private conversations are also going to the cloud. How much of a disaster will that be? So in Facebook, it's still a guess. You still have to have some estimators, some good algorithms to find out who will win, who will be the next Prime Minister. And they'll do a good job of it, trust me. These are all NSA guys. I mean, it's not Facebook guys who will be working on Facebook data. Facebook has its database completely open to the US security. They have all the backdoors. For whatever they're talking about, they have backdoors. So much so that threat perception is that a lot of people in the academic circles, they tell me, oh, we have crypto, quantum encryption, which is coming out, we're all hanky-dory. No, trust me. The Chinese and the Americans, today, they're collecting your keys, the encryption keys that you use to encrypt data and send it across. Your keys they're collecting. Why? Because when you go to the quantum world, when you start applying all the quantum encryption, they already have the keys and they can still break you. So there's a lot of conception that security have this sexy looking algorithm. You can have the world of algorithms, I'll tell you, but you are as susceptible to hacking. If I want to hack you, I will hack you. That's as simple as that. So if you don't want to be hacked, you just be a layman where people think, okay, I don't care about you, so your data is safe. But if somebody cares about you, your data is hackable. You talk quantum, you talk Mars technology, it'll be hacked. So this is where the sensitivities are coming in. What I get to hear from circles is China already has a database of all the keys that are commonly used in India. Americans, of course, are doing the same. It's not that they're anything special, but it's like I have a key to your house, but I will not rob it today. I will wait for you to install the most enormous security gadgets on earth, and then I'll come and hack you. Because thinking that it is very secure, you then start what was there in your bank locker, you bring it and put it back into your home, saying, oh, it's the safest and the greatest place, then I'll hack you. So these are the sensitivities. I'm just laying bare some of the 5G things around 5G, security, politics, and standardization, where it stands, some of the IPR concern that we have. We're trying to address most of these issues in TSDSI. TSDSI is an organization where I think many Indian companies should come and participate, academics, Indian companies should come and participate. And with that, I'll close my talk. Thank you.
Thank you for this scary talk. Any questions from the audience? Any quick questions? Nobody is concerned about data being theft from Facebook?
Thank you, Mr. Satish. Wonderful talk. It's pretty in-depth, and I know you are in a practical world with the geo. You are speaking out from that angle is a lot of values to it. So one thing coming from academia side, so you said about that scheduling algorithms, particularly above the file layer, and when the traffic is coming into any of these access point or base stations, a lot of work has yet to be done. So any group of inside your organization, Geo, working on that, or we can discuss with them? That's my question.
Of course.
Because we know some of the complexities, but I agree with you what you said, but it's pretty complex. But
yes, there are quite a few angles that we are going ahead with and trying to solve. So essentially, from a commercial point of view, what we think is, if we get about 4x or 5x gains when compared to 4x4 versus 64x6, then it makes economical sense, because the cost is linearly expanding, but then I can have more capacity. It's justified. So to go from anywhere 1x to 4 or 5x, we are looking at a lot of things. In massive MIMO, one of the key challenges is to know the state of the channel, the instantaneous state of the channel. That's only one part of the problem. Assuming that we're not even touching that. Assuming that 3GPP you get repeated CSI reports, which is your channel state indicator reports, as early as possible, and you have some good estimator. That's one part of the story. And we're also trying to solve what are you doing with the data. Then comes the question of what are you doing with this channel state of data. So you have to respond to a certain set of users. So MIMO is predominantly an art of grouping the right set of users so that you can have a particular beam in a particular direction. The biggest problem is I have massive MIMO, I have 64x64 massive MIMO, but I don't even know where the users are. The location of the user is not known. Without knowing the location of a user, I need to cook up mechanisms where I am perfectly pointing a beam at you and I'm tracking you. That's a hard problem. Agreed, that's a hard problem. It's not an easy problem. But then again, of course, AI, ML, a lot of things are going on. It's essentially an estimated problem. How do you estimate? But the problem is I don't know anything about you as a user. In sense, whatever CSI report I got, that is all I get. But then in a circle, it's a circle. You can be anywhere. It does not necessarily mean that you are at some particular point. That localization has to be done. Marrying a mechanism of localization to this whole business of scheduling beams versus number of users in a beam versus the goodness of the channel versus whatever other challenges you have.
Plus scheduling.
The scheduler has to account for all this stuff. Earlier scheduler was, you get some QoS parameters and based on which, I dump something. Good or bad, whatever, doesn't matter, because averages out. It averages out over a period of time, and much of the data experience is mostly based on the average, and it does not necessarily rely on the instantaneous values. But here, you have mobility. So the CSI changes very fast, which is not the case. You're not trying to address the QoS, but you're trying to focus the beam itself. You're wrongly focused on a beam. Your signal strength tanks from here to here, and it's a disaster. So we are trying to suggest a lot of algorithms from our own side to vendors to try to expedite this entire thing. You leave it to them. We don't know when they'll come back or what kind of research they do. This is what we are trying to do. And of course, there's a lot of academic interaction which will help, of course.
I will also ask you a question. So while we all agree that Chinese have the data, Facebook has the data, NSA has the data, is it not passing through the operators? So why would I not trust that all the data is also accessible to the operators?
So that's the whole point. So if you see, there's a big, the very bigger picture. It's a very bigger business picture is this. So there is this data guys who become very powerful over the last 10 years. And there are the operators. Operators were big sometime back, 10 years back. now they are seeing their volume, their control is dwindling in terms of their, they've become a pipe. They've just become a pipe. They don't want to become a pipe. And data guys, they want to integrate the data into the network. And that's precisely all this cloud and all this stuff. So wherein you have mechanisms where you can simply bring in the data onto my network, and I can be a